Thank you, Francois. Up next, we have Rachel Thomas and Jeremy Howard, the founders of fast.ai, joining us from Australia. We are thrilled to have Rachel and Jeremy sit down for a fireside chat to discuss why they started fast.ai, how it progressed from classes to a now software platform, the importance of community, and the future direction of fast.ai. Rachel and Jeremy, thank you for joining us, and please take it away.
Hi, my name is Jeremy Howard, and I'm a co-founder of fast.ai.
And I'm Rachel Thomas, and I'm the other co-founder of fast.ai.
Fast.ai is a self-funded research, development, and education organization. And we're doing this first ever co-founder, no fire here, but fireside chat, on lounge chat, looking back over the last 5 years, where we've come to, why we've got here, what we're working on. Pretty excited to bring you this today. Just by way of background, personally, unlike Rachel, I don't have a technical background in terms of my education. I studied philosophy at university, but I spent 10 years in management consulting, 10 years running startups in Australia, and 10 years running startups in America. Most recently, before fast.ai, I founded the first medical deep learning company, just called Analytic. Before that, I was the founding president of Kaggle. Rachel, on the other hand, what's your background?
Yeah, so I have a PhD in math, and I had studied math and computer science as an undergrad. And I feel like I've done a little bit of everything. I worked in finance. I worked as a data scientist in the tech industry. I taught at a coding boot camp. I've taught in a master's of data science program.
So another interesting point in time right now is that we've just moved to Australia. So it's also interesting to reflect on the future of fast.ai now that we're here.
I believe this is our first talk from Brisbane, Queensland. Yes. We're very excited to be here.
So how's your g'day? I hear a g'day from you?
G'day, mate.
Oh, terrible. We'll work on that. So let's talk about why we started fast.ai. So can you talk a little bit about what made you enthusiastic about the opportunities of deep learning and artificial intelligence, but also concerned?
Sure. So and this really goes back kind of before fast.ai. I remember in 2013, I believe it was, reading in the New York Times about Geoffrey Hinton's team winning a drug discovery competition using deep learning.
A Kaggle competition, in fact.
Kaggle competition, yes. And they had it had been like a very last minute entry, and it was just like, wow, this is really, really powerful. And at the time, I was interested and wanted to learn more deep learning. And it was very, very hard to find practical information. Most of the materials were just kind of very, very theoretical math, and they didn't give you kind of the code or what you needed to implement solutions. And I felt like I have a PhD in math. I'm working as a data scientist in the tech industry. If it's this hard for me to get into the field, what are most people experiencing?
And I will say, I was very excited about deep learning as a technology. So I had worked with neural networks over 20 years ago, and that was in a retail banking environment on about $2 million worth of hardware. And I thought, wow, this is fantastic what we can do. And this was all around marketing applications in financial services. And I thought, this is the future. But also, it's not something everybody could use because, it's costing $2 million. We needed basically a whole retail bank's worth of data to get anything useful. And so I kind of put it aside. But then at Kaggle in particular, I saw competition starting to be won by deep learning. And I thought, okay, it's finally happening. I knew it would happen, and it's finally happening. And I actually did a talk, which you can find on TED.com, about both my enthusiasm and my worries. It's called something like the
It's like the terrifying implications of computers.
Yeah, wonderful and terrifying
Yes,
implications.
wonderful and terrifying.
And like, much to my surprise, that's now had over 2.5 million views. And I don't feel any differently now to how I felt then. Just like, what was that,
I think that's
2012?
2014.
2014. Neural networks have a fundamental theoretical reason why they're special, which is that they can kind of theoretically model any possible function. And with the development we saw of GPUs around the 2013, 2014 timeframe, that became practically usable as well. I thought, wow, this is great. There's this incredibly powerful tool that we could use almost anywhere. And thinking back to kind of my management consulting days, I was thinking, like, look at all the opportunities in industry for this. But at the same time, I know the kinds of problems that get solved with the technology and how it's used really depends on who's doing the solving. Did you want to talk about that? Because I know that's something you have a lot of opinions about. We talked about back at that time and why we started Fast AI.
Yeah, so I kind of, at the same time, I was both getting interested in deep learning as well as frustrated with how inaccessible the field was. I was also getting frustrated with the tech industry, and so I kind of had this experience of experiencing a lot of sexism and toxicity during my PhD in mathematics and academia, and had initially been excited to switch into the tech industry and do something different, and then becoming disillusioned with the tech industry and finding like, wow, a lot of these companies have very, very toxic work environments that drive a lot of people out and kind of appeal to a very homogeneous group. And so I was becoming increasingly concerned, kind of seeing like, okay, deep learning is this really, really high impact technology that's going to change the world, but we have a fairly homogeneous group that's able to use it.
And we saw that, right? Like, a lot of our friends were in those groups. And so they're people we know and liked, but at the same time, we can see they were all working on, this small set of problems around
they had all studied with the same handful of PhD advisors, right, a small, this tiny handful of schools.
And they were working on like social networks, advertising, photo sharing. And like, we were thinking, like, where are the people working on disaster resilience or water access or global education?
And as well, kind of the people with the deep domain expertise in those fields. And so not kind of techies applying this to fields that they don't have the background in, but also kind of where are the people who have the background in those fields.
Yeah, because using deep learning effectively, like any data-driven tool, requires data and a deep understanding of the problem to solve it to, the constraints for solving it, and the opportunities. And so we both found that the people that were best able to drive the development of data products tended to be domain experts rather than kind of data scientists. Mm-hmm. So we thought, okay, how do we make the most of this? How do we help make the most of this technology by helping enable domain experts? The other thing that was driving us at the time was kind of looking at history. When there's a step change in technology, it can often lead to a lot of hardship, a lot of problems, a lot of kind of issues around society. So, for example, if you look at the history of the Industrial Revolution, that was not at all a smooth change. There was many decades, or possibly even 100 years, of a decrease in the median income, of a lot of people going hungry.
Yeah, children working in factories 12 hours a day, kind of very terrible working conditions, lack of workers' rights, that it made many people's lives materially worse.
And there's fundamental reasons why that happens. When a new technology comes along, generally the people that can access that technology are the people with capital. And so then they can spend that capital to harness that technology, thus getting more capital. And so it can, at least for a while, increase inequality.
Yeah, it can kind of create a centralization of power and a centralization of capital.
Which is not to say don't have technology. What we wanted to do is to think like, oh, can we find a way to help make a smoother transition? Everybody's able to harness the technology and everybody's able to benefit from the technology. So we decided together to start fast.ai. Did you want to talk about our ideas about how we might be able to make a dent in this problem or this potential problem?
Yeah, and so our approach kind of had several prongs. Uh, we decided to start by teaching a course, and that was kind of a test bed for us to find what are the pain points, what are the things that can be improved, and what are the hardest questions when it comes to kind of the practical implementing things. And so
Which is not to say that we decided to focus on education as an organization, but it was rather if our goal is to make deep learning more accessible, because by making it more accessible, it means the domain experts can harness it, including domain experts who have expertise in these kind of societally important issues. So if we're going to make it more accessible, then it felt like, step one was figure out what's already available, what we can already do, and show people how to do that. But that was just the first step.
Yes, yeah, and ultimately, and this already has involved a lot of research and software development. So we kind of see the four prongs of fast AI as research, software, education, and community. But I think even to motivate, we wanted our research to be high impact. And so in order for that to be the case, we had to see what are the pain points in the wild. What are the things that are keeping this technology from being accessible? What's the low hanging fruit here? And so the research and software development have really been driven by the information that we get by teaching the courses and by having kind of this community of practitioners all around the world working on a variety of applications.
Yeah, so let's step back for a moment and think about what this end goal might look like. So what would it look like for deep learning to be truly accessible? Well, it would mean that everybody can use deep learning who can take advantage of it in their jobs, in their hobbies, in their passions. Now, most of the world, by far, doesn't code. So if it's going to be accessible, then it can't rely on code. Most of the world doesn't have access to data centers full of GPUs, so it can't rely on too much compute. Most of the world doesn't have access to hundreds of millions of rows of data, so it can't rely on that. So, and most of the world doesn't have a PhD in math, also some do, so it can't rely on that. So we kind of came up with this idea of developing an iterative loop where the loop, it's kind of a spiral that eventually, hopefully, ends up in a situation like where we are now for the internet, where my 80-year-old mum uses the internet every day, but she doesn't know how to set up TCP/IP subnets, masks, and she doesn't have to know how to set up PPP or whatever. She just does stuff on the internet. So that's kind of where we want to eventually get to.
I think another good analogy is spreadsheets like Excel. And that's something where people are using Excel across a ton of different domains. And while there are Excel kind of power users or experts, you largely, though, a lot of people are proficient at Excel, but their expertise, is in whatever domain that they apply it to. But it's a tool that's in a lot of people's toolboxes.
And they don't have to know about assembly language and microcode architectures and whatever. Exactly. So the spiral that we hope to get to that point involved initially starting with education, which is to say, okay, here's the software that exists right now. Here's the data that you can find right now. Here are the techniques that are available right now. Here's what you can do with them. Here's what you can't really do with them. Here are where the opportunities are right now to take advantage of this. Here are the pain points. And so that became the first version of course.fast.ai, which, it was a huge experiment.
Yes.
Because a lot of people didn't think that this would be possible. It wasn't like there were any other general deep learning MOOCs for a kind of non-math, non-graduate audience, right?
Right. Yeah, and it can be hard because things have changed so much since 2016 when we ran the first version of the course that it can be hard to remember kind of how few resources there were, and that the resources out there were primarily kind of theoretical math, building from first principles. What do you need to just understand the math theory behind deep learning, but less so about implementations, much less cutting edge, state of the art implementations, which
Yeah.
was always our goal and was always part of the course. That we never wanted to just be using toy examples or things that were kind of not good enough performance to actually use in production, but to really be taking people to the state of the art.
Also, I remember as we started out that first course, there was a lot of pushback from folks we knew in the deep learning community around this is giving people ideas like above their station. People aren't going to be able to handle this. If they don't have a graduate math background, they'll give them the impression that they can do anything useful because frankly, they can't. Do you remember that?
Yes, I do. And I also remember seeing a lot of advice of, someone would say they were interested in deep learning and they see this on sites like Hacker News, and then someone else would post like, oh, these are all the textbooks you need to buy and you need to, start with kind of learning all these areas of theoretical math and, coding in CUDA and kind of writing your own compiler and things before you can actually start learning deep learning.
Yeah. So, anyway, we were delighted to find that this experiment, which, honestly, as when you're doing something new like this, it's hard not to listen to all the negativity. And we were certainly concerned maybe we would fail, but we'd give it a go. And yeah, we were amazed that this totally new, unknown, unfunded organization, the very first course we put out had hundreds of thousands of people taking it and kind of instantly transformed almost the way people talked about deep learning education. And within a year of us putting out this course, I feel like the phrase democratizing deep learning went from an unknown, weird, impossible dream to almost like something that everybody was talking about, didn't it?
Yes, yeah. And the other thing is, most education tends to be bottom up, and we've talked a lot. Most technical education tends to be bottom up.
So starting with the math.
Yes, and you have to learn each building block you're going to use, and then in a few years you'll be able to stack these building blocks into something interesting. And so we wanted to use this top-down approach. And while we had read about it from authors like David Perkins and other fields,
Paul Lockhart,
I had never heard anyone apply top-down education to deep learning before fast AI. And that's something that we got a lot of skepticism about as well, with the idea that we're going to get people.
Well, not just skepticism, but almost this kind of angry kind of like, okay, you're showing people how to do stuff in lesson one to like run some pre-canned model, but this is dumbing it down.
Yeah,
they'll never be able to do anything
useful. They don't understand all the details. Yeah, the dumbing it down accusation. Yeah, a lot of people said that. But really the idea was that in each subsequent lesson, we were digging into more and more low level details and getting lower and lower levels. And
we ended up being the only ones actually, or some of the very few that actually taught like, how does automatic differentiation actually work? How does backpropagation actually get done on a computer in a performant way?
And by part two, so our first year of the course, this was spring 2017, we were implementing papers as they were coming out during the course. And kind of that was...
I remember we did the 100-layer tiramisu.
Neural style transfer was relatively new then. And our goal was to teach people how do you read a new paper and implement it yourself.
Yeah, so, but at the same time, the outcome of that first course, it did show us the key thing we were trying to figure out. Well, there were two things we really wanted to know. One was, is there any point doing this at all? Is it possible for people without a math PhD to do useful work? And the answer was, oh my God, yes, it is. Like lots and lots of students came out of that course doing breakthrough work, getting published in academic papers, getting patents, building startups. But the second thing we wanted to know was, where are the hard edges, And we found a lot of hard edges. In fact, pretty much anything except computer vision, object recognition was almost impossible to do in practice, outside of academia. So from that, after that first course, we went fully into research mode. So that was kind of the second part of our spiral. So education, research. And one of the big wins there was we thought, well, how do we turn these great computer vision results into great natural language processing results. And out of that research came the UlmFit algorithm, which basically said, you know what, you can just use the computer vision ideas directly in NLP and they'll work. And so that's what UlmFit was. I coded it up in like 4 hours and it worked first time. One of the challenges for the idea there was that I spoke to lots of NLP researchers before I tried this, and all of them said, it's not going to work. All of them said, NLP is different, it's special, forget it.
And then the core idea Jeremy's talking about is using transfer learning. So, for instance, training on text from Wikipedia first, and then applying that to a different corpus of text for kind of fine tuning your model.
So like that was a great example of the research that we had to do. And then it was really cool because I presented the research actually in a class, in a part 1 class actually. And then a great PhD student called Sebastian Ruder saw the video and said, that's publishable, and I was like, I don't know how to publish this. I don't know anything about publishing. I'm just a philosophy graduate. And he was like, all right, I'll help make it happen. And so him and I wrote it up, and he helped with lots of experiments and wrote most of the paper and got published in the top computational linguistics conference, which was
ACL.
Yeah, which was amazing and kind of helped kick off this modern era in NLP. And so that was also a nice kind of tick for our idea, which was like doing the course, finding a hard edge, which is like NLP's doesn't really work. Everybody doing NLP at that time were doing almost everybody were doing pretty academic stuff like, entity recognition or kind of parsing. They were like sub-problems that you couldn't hand it to somebody in an organization and say, here's how this solves your problem. So I just wanted to do something very directly applicable, like let's just get classification working.
Yeah.
So it was cool to be able to say, okay, this approach of taking our learnings from the course and using it to solve a problem in research. And then the next thing we did was software development. So this was built very heavily on top of Stephen Merity's work with AWD LSTM, which was research code, good code, but research code. And so it was nice to be able to then take that along with some code that James Bradbury developed and start to build a library around it. And so then we were able to kind of put that out on the internet and say, okay, there's now this thing called the fast.ai library, and there's a thing called fast.ai.text, and you can install that and use UlmFit yourself. And we had a script that was, a dozen lines of code that will give you the same results that we got in the paper. And so this was kind of getting up to step 3, the course, the research, and then the software to implement that research. So then the 4th pillar is community. Would you want to talk about that a bit?
Yeah, so we have, so the courses, actually I should probably give us some background. The courses prior to the pandemic, we used to teach in person at the University of San Francisco. It was an evening course, kind of open to anyone, not for, you didn't have to be enrolled in a degree program at USF. We had from the very, very start, we had diversity fellowships, we had international fellowships to have people from all over the world participating in real time, to really try to build a kind of diverse and varied group of people taking the course. We also had something that was amazing to us and kind of unexpected is people for the later courses, we would have people come from around the world because they wanted to take it in person and be a part of that community. But we also had a very active online community at forums.fast.ai.
And the reason we built that up is because we thought, okay, like a lot of these people going through the course and using our software, were, as we hoped, domain experts, but often they would be the only people at their companies to be using deep learning or interested in deep learning. And that would be pretty isolating and pretty difficult. So by providing an online community, it was really helpful because people could find each other, could help each other. A lot of people were trying to break into jobs, so people helped each other with interviewing, people helped each other with reviewing their projects. Without that community, we would be missing the critical piece around people helping each other.
Yes. And we've seen that with so many Fast AI alums kind of writing blog posts, answering each other's questions, starting podcasts. There have been examples of Fast AI students kind of live coding together while they're in the course, often kind of remotely. We had a study group going during the course, but that component of helping each other and learning together is so important. I have to say, one other thing that we emphasize and have from the start is ethics and kind of the importance of really thinking about the impact of our work and the ethical implications of it. And that has been a part of the course. And really including it kind of as a core part. Something I love is in the book, which is, this is deep learning with fast AI and PyTorch software libraries.
Deep learning for coders. Mm-hmm.
Deep learning for coders. Chapter 3 is on ethics. And we really try to keep that front and center, that ethics is not some add-on elective and it's not tucked in an appendix at the end, but to really have that as an integral part of the course and of the book, to really think about what are the risks and harms of potential misuse and what should we be doing to very proactively prevent and address those.
It's kind of even more general than that. It's like throughout the course and throughout the book, it's all about practical. So it's all about like, what does it take? How do you get the data? How do you deploy the model? So like chapter 2 of the book is all about deployment.
Which also I think is great to start with deployment, because that's also something that tends to kind of be forgotten or just tacked on at the end.
Yeah, I mean, a lot of the kind of academic folk who teach wouldn't know how to deploy, so they can't talk about that. And throughout that, it's all about like, well, how do you avoid feedback loops? Where do you need a human involved? And so the kind of the ethics component is very tightly knit with just the practical development of data products. Having said all that, I feel like we're just scratching the surface towards our goal. Deep learning is still very exclusive because as it stands, you still need to know how to code.
It's also still a overly homogeneous field. We do not have the diversity that we need yet.
Yeah. As you do our course, although you only need high school math to start it, we teach you a lot of additional math on the way, which is, we kind of need. I mean, the vast majority of people in the world are still not able to harness deep learning effectively. So, which is fine. We didn't expect to solve our problem in 5 years. I think we're very happy with how far we've got thus far. But, from here, like what's next for Fast AI? Our focus has been moving gradually from education as being kind of the initial thing we were working on, more and more then towards research, and then more and more towards software development. And I think we're going to keep heading in that direction because the software development is the thing that, it allows us to actually remove the barriers entirely. If you can get to a point that the software is so capable and so easy to use that you don't need a course, you don't need prerequisites, then that feels like the only way we're actually going to really solve this problem, especially if that software will run on any computer and will work out of the box with small data sets. This feels like the way we eventually remove the barriers entirely.
Yes. Although I would say we are planning to teach an in-person course in Brisbane, and that this goal of software development is still the goal of software being kind of all you need and no education being necessary is still, I think,
probably many years away.
Many years away.
So we're still doing the loop. We're still doing
the loop. Do you want to say more about our move to Australia? What that means?
Yeah, I mean, I'm not sure means much. We're still doing the same 4 things, and we're still doing it in the same iterative way. Hopefully the course, it will probably stay the same length. 14 lessons, two parts of 7 each. But what happens is each year the amount we pack in gets bigger, because thanks to the software and the research, there's less to teach, and we can do more with less. So hopefully we'll just keep this process of each year, at the end of the 14 lessons, you'll be able to do more and more and more. And also, we also kind of hope that, and we're finding this is working, the more we do the course, the fewer lessons most people need. We don't want you to do all 14 lessons. We actually want you ideally to have to do no lessons, which is not where we're at now. But where we're at now, I think a lot of people just need 3 lessons to make a reasonably good start. But hopefully we'll keep making it so that you can do more with less. The answer to what now that we're in Australia is things will continue to look much as they do now. I think, Rachel, actually, you've been involved. We've been focusing on ethics for the last couple of years now.
Yes, yeah, and particularly the last 2 years. I was founding director of the Center for Applied Data Ethics at the University of San Francisco, so that was my full-time focus.
But hopefully now you might have a bit more time to
get back into fast.ai more.
Can't wait.
I'm excited for it.
Yeah. So thanks everybody for joining us, and I hope you enjoy the rest of your conference.